Okay, I think we're about ready to start presenting. So welcome everyone. My name is Mirva Saarijärvi. I'm from Wirepass, and this is the webinar by Wirepass and Redlaw, and we're discussing supply chain visibility through IoT Mesh. The agenda today here is that I'll be doing some introductions of the speakers, and they will tell you a little bit about Redlaw and Wirepass. And then we'll go through some solutions for the supply chain, and we'll show you some case examples and benefits and explain how the technology works. Nick from Redlaw will be showing you a demo video and discussing that. And he also has an accelerator kit offer for you to have a look at. And in the end, we'll have a Q&A session. And I invite you to send your comments and questions to the questions section at the webinar, and we can go through them at the end of the webinar. First up, we have Nick van Dierdonk. He's the CEO of Redlaw. He was formerly the founder and CEO at UbiWave as well, and he's got a background in the automotive multinational and GM of and has been a GM of several automotive manufacturing plants. Then we also have Ben Corrado. He's head of US for Wirepass. He was formerly founder and CEO of Rigado and has also worked at uBlocks, Garmin, and Andrews Cooper Consulting. Now I'll give the floor to our speakers.
Thanks, Mimi. Really appreciate it. Thank you, everybody, for joining today. So this is Ben from Wirepass. I'm going to go through a little bit about what we're focused on over at Wirepass first. And it really comes down to building a solid, reliable mesh connectivity layer for all of your devices out there in the logistics and asset tracking realm. So we want to make sure that it's the most reliable solution out there. It's optimized, it's scalable, and it's simple to use. And we provide all of that in a software layer, so it all runs on top of existing chipsets like NRF52 or EFR32, chipsets that are very prolific out in the market, so very easy to get implemented in the hardware realm and run our software on top of those industry standard solutions. On top of that software, we focus on making everything be scalable, and that if you have a mesh of just 2 devices all the way up to millions of devices, Wirepass is there to support you all in one network, all with one homogeneous solution that can work across an entire large-scale network, as is often required in asset tracking and logistics solutions. And finally, we know that building IoT solutions requires strong ecosystems. And so we focused on building up great partners with hardware and turnkey solutions that can provide those to end customers to solve all of these different needs in the IoT market. So we do all of that by providing the software layer in the green diamond here on top of that hardware I was mentioning, and give you the ability to run different applications on top of all of that using our SDK. Redlaw has taken great advantage of that and built in lots of great features onto that SDK that we'll talk about today. And then once you deploy those nodes out in the field, they automatically form a mesh network that is self-determining and auto-healing, and connect to any number of gateways where we provide open source gateway firmware and software that runs on that, and tie that up to either a cloud or an on-premise server that's running a positioning engine that gives you XYZ coordinates of where different devices are, networking tools that allow you to debug, diagnose, and deploy the network, as well as tying into general IoT cloud tools like MQTT. And so those come in a variety of different hardware solutions, as you can see up above, different sensors and gateways, and people implement their own dashboards or use great dashboards from people like Redlaw to be able to enable these solutions to be useful for data analytics and deterministic decision making for their end customers. So now I'm going to turn it over to Nick to give a little bit of a background about Redlore and the solutions that they're working on with us. Nick, you're still muted, I think.
Okay, thanks, Ben. Thanks, Ben and Mimi, for the introductions. And also to all of you for turning up in such great number to this webinar that we're doing together with Wirepass. So about Redlore, we're going to be talking about our solutions for supply chains and manufacturing. We're an IoT solutions provider. We provide end-to-end solutions. And what that means is we start with designing and building the sensor devices, or call them the smart asset tags, especially in supply chain application. We have a variety of off-the-shelf products with many different sensors that we use to cover the requirements of the different applications. And for specific cases that go high up in volume, we will build custom hardware. The sensor devices will connect up to a dashboard where the insights, the data and the insights generated from that data are displayed. And in between those sensors and the dashboard, you have our cloud IoT engine where a lot of the hard work is done, and we'll come back to that later. On top of that, we also offer a suite of deployment tools because together with our customers, we've discovered that especially when installations get large, then the installation time and installation efficiency become an important issue. One particular item I'd like to mention up front, and that's one of the things where we focus on and we do it different from many of other players in this field, is we put a lot of analytics in the sensor device itself. We have an analytics engine running on the sensor device that can be programmed to do all sorts of algorithms, to run all sorts of algorithms that basically reduce the sensor data to insights. They reduce the data load, and that allows them to spare the network, to use less of their battery, and to send exceptions to the system in the cloud rather than send raw data. And one very good example that we'll come back on later is when your goods are in transit, you still want to be able to discover if the temperatures have breached the valid range or if the devices have taken a shock. So you still want your device to be up and running algorithms, running the analytics, even when there is no connectivity to the cloud. And then finally, why are we on this call, on this webinar together with Wirepass? We have decided early on to standardize on the Wirepass Mesh communication system because it's an excellent fit with the needs of supply chains. If you look at supply chain IoT applications, it's very often about you need highly scalable technology. We often see thousands or tens of thousands of devices that have to coexist in a single supply chain. On top of that, we've extensively tested and used the Wirepass system in harsh environments, and that's where the robustness and the plug and play aspect of the Wirepass Mesh plays very strongly. And then last but certainly not least is the low power routing capability. And many people who are not technically experts in IoT tend to overlook this, but in IoT applications in supply chains, you don't have the luxury of being able to deal with things like network planning, doing a lot of wiring, etc. And that's where the Wirepass technology, where every sensor device can also act as a low power router for other devices. That's where Wirepass is very strong. Next slide. So let's talk about a number of solutions that we offer specifically for supply chain applications. So one is warehouse management. We'll talk about that later, as well as about our solution around supply chain asset management. There is a third solution set that we offer for cold storage monitoring, but for reasons of limited amount of time on this webinar, we'll skip that third one, and I'll invite everybody who is interested to know more about that to organize a one-on-one call after this webinar. Next slide. So let's dive into the matter. First application, first solution is for warehouse management. So warehouse, as most of you will know, is a very complex environment. There's a lot of assets and there's a lot of processes happening with these assets. So the solutions we bring to the table here is, first of all, around where are my things? It's about where are my goods that live in the warehouse. But if by handing out tags to people, you can also position within the warehouse the employees working there, the people who are present there. On top of that, we also offer a solution to track your forklifts, especially in larger warehouses. It can be interesting to know where your forklifts are at any moment in time. And we'll talk on the next slide about how this all works from a technical perspective. But to finish off the use cases, a second big block of solutions we provide is all about diagnosis, about condition monitoring. Some of the assets in the warehouse will need to be stored within a certain temperature range, humidity range. Other assets will need to be protected against a shock, like a fall or a lateral shock coming from, for example, a forklift. So those are the type of things that our solution will show you in the dashboard in near real time. And on top of that, there's also forklift monitoring. So there is a positioning, but there's also a number of things that you want to monitor on your forklift, because a forklift is both a very expensive piece of equipment, and also you cannot operate your warehouse without. So there we're talking about monitoring acceleration of the forklift, monitoring abusive braking, because both those things will lead to higher wear and faster maintenance cycles. And we'll also manage or monitor better the battery and the operating time of the forklift. And then we move to a number of process support features that we offer as part of the solution. One is obviously inventory. You want to know at every moment in time what the inventory is and where it is. So there our solution will automatically and continuously take the inventory and allow you to pull a report of that inventory. And along with the inventorizing, there's also the feature of automatic incoming inspection. People who are working in quality-driven industries, such as automotive, where I'm coming from myself, or defense, or many other industries, also many of the just-in-time industries, know that there is often an obligation, a quality obligation, to do inspection on the incoming goods. So there, our solution will provide you with the count of boxes coming in, with the identity of the boxes coming in, but it will also automatically report on anything that has happened to that box, that bin, or that pallet before it arrived at the warehouse. A few other things to mention: goods in, goods out, cross-docking. Those are processes we support with our solution. Picking support, in that use case, you will attach a smart asset tag to the rack location, and you can feed your picking list to our system from your warehouse management system, and it will, the field devices, the smart asset tags on the racks will start blinking an LED to indicate and to help the picking operator pick the right goods. And then as a last application, consignment stocking. So also very pervasive in just-in-time supply chains, where you as a supplier, you stock your finished goods in the warehouse of your customer. And it's very important for you to know when the customer has consumed from this stock, because that's the moment when you want to send him an invoice. So that's what our solution will tell you. It's also automatic and continuous. And on top of that, it can tell you when boxes have been opened in order to solve for cases where customers will actually open boxes and partially empty boxes when they're still sitting in the consignment stock. Okay, let's go to the next slide. where we're going to speak a little bit to how the solution works. So starting at point 1, item number 1, the light green dots are your smart asset tags, and you're gonna attach them to the pallet, the bins, the boxes, the tote, or whatever container or unit you want to use to track your the items in the warehouse. Then you have the dark green dots, and those represent what we call anchors. An anchor is very similar to a smart asset tag, except that it's not attached to a pallet or a bin, but it's attached on some fixed position in the warehouse. And those devices will help feed data into the positioning engine to allow you to position all your pallets and bins. So all these devices, both the anchors and the smart asset tags, form one big mesh wireless network and report their data to a gateway. And a gateway is a little device that sits somewhere in the corner of your warehouse, and it will connect up to our cloud IoT engine via a cellular connection, Wi-Fi, or Ethernet. And so the cloud IoT engine is where a lot of the work happens. The engine is responsible for ingesting the data, unpacking it, pre-processing it, and putting it in storage. On top of that, the cloud IoT engine also does a lot of mapping of the data to the application model. And I think this deserves a few words of explanation, because it's something that we often have to explain to customers who are rather new at IoT from a technology point of view. So what this mapping really means is, to give an example, let's say you're operating warehouses in 5 different countries, every country having, for example, 10 warehouses, and there is a warehouse manager responsible, and he has a few clerks. Well, you want to map all those devices and assets to a specific country, to a specific warehouse, and you want to assign rights to the individual people as to what information they have access to. So it's basically almost like an ERP system for IoT devices. On top of that, the positioning engine is also embedded within the cloud IoT engine, and the cloud IoT engine can run custom analytics. So now, of course, you want to visualize your data. Once the data is processed and is transformed into knowledge and insight, you still want to visualize it, and that's where we offer Redboard. And Redboard is a customizable, programmable dashboard platform. So it's not a fixed view, it's really something that you can configure and change to meet your own needs. If you're the end customer, or if you're an integration partner of ours, then you can use it to model it to the business of your end customer. The dashboard will also allow configuration of alarms when an email is sent, when a text message is sent, and it will also allow you to draw reports for compliance reporting and monitoring. Now, perhaps you already have an ERP system or a warehouse management system or any other data backend, and you want to pull the data directly from the cloud IoT engine. So that too is a possibility. You don't have to run through the Redboard dashboard. We offer standardized interfaces through an API, but also through a lightweight MQTT connection to connect to whatever data backend you want to connect the information to. Next slide. So to summarize the warehouse management applications, so it's a very easy to install system, because you basically don't need to pull wires, and wiring is one of the more expensive things as soon as you get into buildings and warehouses. Noteworthy is also the AES-128 security that is embedded in the full communication chain, because there's going to be business critical data running on these systems. Last point I'd like to highlight is that all the devices that you saw in the previous slide can be reconfigured over the air. So when you want to repurpose a device, you want to activate different sensors, because you're going to be using the devices maybe on a different pallet or on a different bin for different application. Everything can be done remotely over the air. You can even replace change, update the whole software running on the devices. Next one. So let's talk a little bit about the second application, supply chain asset management. So this is really our solution for continuous in-transit monitoring. So suppose you're moving goods from one warehouse to another warehouse, and perhaps to a third or even fourth warehouse. And in between those warehouses, you're going to have transport. Perhaps it's going to be multimodal transport. And you want to know what happened to your goods when they arrive, or even when they're in transit, and you want to know if something happened that could have compromised the integrity or the quality of the goods. So the problem today is that there's very little visibility over that part of the process. It's very hard to get a spoilage alert when the goods are on the way. And if the goods do arrive in a compromised or in a damaged state, it's very hard to find ultimately who has the responsibility. It's very hard to agree on and figure out where exactly in the process things went wrong. And that's impeding actually resolving the problem on future logistics movements. The types of goods we're aiming at here are, first of all, environmentally sensitive goods, thinking about fresh produce, wine, pharmaceuticals. On the number two, high value goods, spare parts, where it's very important, for example, a $50,000 machine replacement that you really need to arrive intact in time. And then we're also talking about fragile goods and just generally and many of the goods that are transported in just-in-time supply chains. Next slide. Next slide, please. Okay, thank you. So let's talk about how this works, and you'll see some similarities with the solution that we've presented before, but there's also a number of new elements. So let's start at number one at the bottom left, which is the origin warehouse. So you have your smart asset tags connected to the pallets, the bins, or the boxes, and they all automatically form one big wire pass mesh network connected to the gateway, and the gateway feeds all the information up to the cloud IoT engine. And then the goods leave your warehouse, they're put on a truck, and perhaps in the truck you don't have your gateway doesn't have a cellular connection, or maybe it won't have a cellular connection all the time at least, or maybe you don't even have a gateway on the truck. Well, the devices, thanks to the embedded analytics on them, they will still continue to monitor the state and the condition, temperature, humidity, shock, tilt, whether there's been tampering with them. So they will continuously monitor that, and they will record it in their memory until the moment where they actually find a wirepass network and can transmit that data to the cloud. So let's move on to station 3. Let's assume somewhere you're cross-docking your goods from a truck to a ship, for example. You can decide to install a gateway there. So as we said, as soon as the devices see that gateway, they will reinstate the mesh, they will reform the mesh, and that gateway will offload all the recorded data, the exceptions, the alarms to the cloud IoT engine. But even if you don't have the luxury of having a gateway at that cross-docking point, then any operator who has a smartphone with our app installed on it will automatically receive notifications from the assets, from the smart asset tags on the smartphone to indicate the alarms and the exceptions. And then finally, we arrive at the destination warehouse, where again, the smart asset tags can offload any in-transit data to the dashboard. And very similar to the previous solution set, you can also use this functionality to do automatic incoming inspection, because the devices will basically offload their full in-transit data to the cloud IoT engine, which can be displayed on the dashboard, and reports can be generated from it. Next slide. Over to you, Ben.
Awesome, thanks, Nick, for a great overview of what you guys are working on there. So wanted to take some time and kind of dive into some of the features underlying all of these pieces that we're running in our WirePath stack. So as I mentioned earlier, scale is a big piece of what we focus on. And recently we've added some support to allow for even greater scale over WirePath. So a few months ago, our limit was about 16 million devices in a single network. We had a number of customers pushing us to expand that boundary as they expect to be exceeding it in the next couple of years. So we can now support up to 4 billion devices in one single network. The largest network we have deployed today is about 700,000 devices active in one network. So that means you can take one device from anywhere in that network, drop it somewhere else without any reprovisioning, reprogramming, et cetera. And that gets that up and going very simply. And to make that scale possible, that really requires the mesh routing topologies that we've developed and patented, and that make all the difference for us. And that relies on basically allowing nodes to make intelligent decisions on their own. So it's a decentralized mesh, where it's using cost-based routing to figure out the best cost back to its data path up to a gateway typically. And so that gives us the ability to measure lots of different things and take that into account. And we're using a lot more spectral efficiency on top of what is possible and pretty much any other ISM band mesh network, where we can take advantage of all 40 channels with this multi-hopping operation across multiple channels to give us both interference tolerance against other 2.4 gigahertz interference, but as well as giving us significantly more bandwidth. So, roughly double the bandwidth that you would see per Zigbee network, and about 4 to 5 times that of a Bluetooth network. We can do all of that in the WirePath solution, and that scales as you add more gateways. So unlike those other solutions, every gateway you add, you expand the capacity of a WirePath network. So moving on to the next piece there, it's really about making it easy to install. IoT, with the massive number of devices that need to be put out there, thinking about deploying millions of devices, these have to be put out by people who don't need to have an electrical or software background. It needs to be simple to install, simple screws or zip ties or double stick tape, so that any maintenance person can provide it. And it can't require complex apps or security codes or anything like that. So we have in-band joining capabilities that don't require the user to know anything about what's going on in the network. They deploy a node. It validates against a backend running on the edge or the cloud to validate that it's a legitimate device, and automatically joins. You can also use things like NFC or other out of band pairing like BLE to bring things onto the network. And similarly with that install, it's about making it affordable as a system, right? So we run on off-the-shelf 2.4 gigahertz hardware that is being made in the billions of devices per year. So the parts are relatively low cost and easily available. Because of that easy installation, you don't have to run as many wires to the system. Because of all of the routers, as Nick mentioned earlier, being able to be battery operated, it means that you don't need to find plugs and outlets and all of that to place all of these devices in. And because the system can self-heal, it means you don't need to have maintenance people out there kind of replacing all of these different sensors when things break and figuring out optimal routing paths and all that. The network largely handles all of that on itself. So we don't have to worry about those pieces, or you don't have to worry about those pieces. WirePass handles that all under the hood. And there's no reoccurring fees for WirePass connectivity. So it's a simple one-time royalty when the hardware is built. And from then on, you're free to use it as much or as little as you want in your applications. And along with that, lowest cost solution means we need long battery lifetimes. So we focus on being able to provide great performance for 24/7 operation of those devices out in the field while running on batteries. So you can get a 5-year lifetime quite easily with a 4,000 milliamp hour battery that's sending about 1.5 packets per second, and a packet's about 102 bytes. So you can get quite a bit of information through about what's going on in your environment, and run that all off a primary cell. When looking at sorry, I got some feedback there. I don't know why I'm getting feedback, but so when you look at this and a routing perspective, a routing device is something that's transmitting multiple packets, can run at about 25 microamps, and a non-routing device is about 12.5 microamps. So when you're thinking about what type of battery lifetimes, that's roughly where things land out. And because of this, we have customers that are getting 10+ year battery lifetimes with lithium primary cells out there. So while battery life is a huge aspect, we also sometimes need really high performance and pushing lots and lots of data through the mesh. And so for that, we have a low latency mode. This is often used in the powered devices. So think lighting or other plug-in devices. We can get extremely low latencies, 10 milliseconds per hop, to be able to do lots of end-to-end fast communication with these types of solutions. And you can get about 150 packets per second with that 102 byte payload I was talking about, while using our low latency modes. So if you need to really push a significant amount of data through the mesh, this is a great way to do it. And both of those modes work seamlessly together as well. So you're not limited to one or the other. They operate, interoperate seamlessly through the network. In all these asset tracking solutions and warehouse management solutions, extreme density really comes into play. So you can think about having devices on a pallet that you need to read out. We can do about 1,500 devices on one pallet, all communicating simultaneously and delivering that data reliably, all in a low power mode. So this works quite well. That's 1 meter cubed, 1,500 devices. And that's because we're not operating everything on the mesh on the same channel at once, and we're doing time synchronized message passing. So it gives us lots of flexibility and the ability to do these very dense networks. We also have an inventory mode that allows really fast scanning of what's in your warehouse, what's on your pallet, what's in your container as you're pulling it up to that dock. Scanning up to 6,000 devices with 100% accuracy within 30 seconds. And this can expand with either more time or more devices, so that you can scan an entire container or pallet or inventory your warehouse in pretty rapid succession using our new directed advertiser functionality. And obviously, none of this would be possible without really high reliability. So that device, or that network I talked about with 700,000 devices in it before, we're getting 99.99% availability at any point in time on that network. And those devices that are not online at that time are usually rehealing themselves into another portion of the network. So they're very quickly available again. And this really comes down to that routing algorithm where the decisions are made locally, so that they can respond to local interferers without impacting the rest of the network. And then additionally, we've really cut our teeth in Industry 4.0 and oil and gas and kind of remote sensing applications. And so we've built a lot of redundancy and reliability into the network with all messages being acknowledged and passed securely. These pieces really come into play when we start expanding the network, all the lessons learned in the past from that. And as you probably picked up, there's lots of different applications besides just asset tracking and warehouse management that you can use Wirepass for. So you can add your lighting, your switches, your air quality, your asset tracking, your people tracking. All of that can all run on the exact same network and use different, essentially what come down to ports effectively on the network, so that you can pass different data through the same network, each with its own application encryption. So giving you the ability to run lots of different applications that can be secured all on one mesh fabric that only needs all the infrastructure installed once. And then obviously none of this is useful without security. So really building in that security level with AES encryption and the ability to do that both are at the network level, at the over-the-air update level, as well as at the application level is critical to any IoT application. It's all built into the Wirepass stack. Additionally, that over-the-air updating is just an inherent feature of Wirepass. You don't need to implement any extra features to do entire over-the-air updates to your entire fleet of Wirepass devices. And then as Nick mentioned, asset tracking, built-in positioning is a huge piece for us. This is core to the technology. All of these can run on battery-operated devices, which means very fast install times with no real requirements for who needs to install them, and gives the system the ability to get a 2 to 5 meter accuracy depending on anchor placement. 10-meter anchor separation is getting you in that range typically, and being able to pull that information anytime, push that up to the cloud through that system or on-premise Docker container. So as Nick talked about, you put out these anchors that ties up with the gateway and backend, and Wirepass is really providing the firmware that makes these anchors possible and automatically form and maintain that mesh. The gateway software that pulls that up and relays that through, and then the positioning engine on the back end that makes it possible to calculate those solutions, and then provides that as a latitude and longitude effectively for where your devices are located. So that's a little bit about Wirepass. Happy to answer more questions in the Q&A. Just shoot us a message, and I'll turn it over to Nick to talk a little bit more about Redwire and give you a demo.
Okay, thanks Ben. I think that was very clear and in-depth explanation of everything, all the Wirepass technology that we use under the hood of our devices. So let's speak a little bit about the devices themselves. We design and build these, and we tailor these to specific applications. What you see in the picture is the RL4 device, which has 11 sensors on board, probably one of the most feature-packed IoT device for this sort of applications. And depending on the use case, we'll activate this or that or a different set of sensors. For this device, we systematically use industrial-grade replaceable batteries, as opposed to your typical coin cell battery. The batteries that we use here for supply chain applications are able to withstand very large temperature variations, which you can easily encounter when goods, for example, are shipped from Ecuador to warm Ecuador to cold Canada, where we're operating. Wirepass is inside of every device. I also saw one question from the audience. So yes, Wirepass is embedded in all of our devices, as is our sensor edge analytics engine, which I talked about later, that, for example, allows you to run much larger networks because every device will only send small data packets rather than just the raw sensor data over the network. The devices are all capable of buffering data when they're in what we call dark mode, meaning when there's no uplink to the cloud available, and they're all remotely configurable and reprogrammable. And last but not least, all the devices are capable of interfacing directly to a smartphone using the onboard NFC interface or using BLE beacons. Next slide. All right, we're going to look at a little pre-recorded demo here. I'm going to try and talk you through that. And the demo is going to show several of the use cases that we mentioned, we discussed before. And during the demo, you're going to see a lot of our, you can click play. You're going to see a lot of the Redboard dashboard where things are visualized, which is this view here. This view gives you a detailed view on the different sensor values of one particular sensor device, one particular smart asset tag. So in the first part of the demo, we're going to look at a temperature application. It's going to show up on the screen in a few seconds. So while we're waiting for the video to move on, just want to repeat that the gauges and charts and the graphical elements you see here are really very configurable and changeable. And if the predefined widgets are, let's move on to the demo. So what you can see here is a number of black totes with a smart asset tag attached to it. You can see it right there in white. These are, in North America, the typical, you may have seen these in supermarkets. They're used to carry milk. And we've taken them out of cold storage and we've put them in the sun. So this is a highly accelerated video. And if you look at the blue line, you can see the temperature is rising from 7 degrees up. It's at 11 degrees Celsius now, going up. So within the Redboard dashboard, you can attach alarms, alerts, to that sort of events. You can send emails, you can send text messages. Every little blue dot that you can see in the graph is a measurement taken on 10-second intervals. In most real-life applications, you're going to relax that frequency to, for example, every 5 minutes, every 10 minutes, because that's going to have a positive effect on your battery life. Then we're gonna move on to the next part of the demo. Here we're gonna demonstrate a fall, a shock. Some goods actually you don't want them to fall on the ground, so we let it fall from about 4 inches onto that pallet. And what you see in the dashboard is that message traveled all the way to the gateway through the IoT cloud engine to the dashboard and created this shock alarm. We just clicked it away in this example, but it remains visible in the log and can be reused later as evidence or just to view the recordings. Here you see a similar type of event. So there's a car, or it could be a forklift, laterally impacting the devices, creating a shock. And in this case, as you see, the separate vibration alarm has also went off. Some goods are very sensitive to vibration, so that's why we implemented that as a separate alarm. This here is a tilt alarm, so let's have a look at that again. The black box is tilted by about 50 degrees. So what you'll see in the demo window at the top left is that the little graphic will show that tilt. You also see in the graph at the bottom left, you'll see that the blue curve is rising up to indicate what pitch was effectively reached. And as long as that pitch is active, that graph will show you an elevated pitch. Finally, in this part of the demo, there's the tampering alarm. So there's a little light-sensitive device, smart asset tag, embedded into that cardboard box. It will raise a flag. It will raise the visual indicator of a box opening. The same things that we did with the bin or the tote as an example, you can do on a pallet. So you can attach the RL4 device to a pallet, and if that's the level of granularity that you prefer to measure at, you can do exactly the same thing. So the pallet will register exactly the same measurements, in this case a roughly 25-30 degree tilt, which you will see replicated in the dashboard. So as I said in the beginning, this is all programmable, changeable, and if you want to define new widgets, you can do so. You can use JavaScript to program entirely new visualizations. So this is the final part of the demo. We're going back to the warehouse application. So you see two forklifts in this example. Those are the red icons. And I'd like to ask you to look at forklift 101 in particular, which is now at the middle, about in the middle of the screen. And it's working its way down to the warehouse, to the building that you see. It came from all the way up front, all the way up there in the laydown yard. And it's gonna take the ramp to enter the building. It's gonna pick up a pallet there. I think it's doing that right now. It's taking the pallet out, you can see it there, pallet 100, and the forklift are positioned together, and it's gonna drop it off at the northeast corner of the laydown yard. So this is an example of the positioning engine at work, where the positioning anchors were installed both in the warehouse as well as on the laydown yard. Next slide. So this is the end of the little video. Happy to discuss more after this webinar if you're interested. Now you may be left with the question, okay, how can I get started? How can I start using these solutions in my own business? So there we offer two approaches. One is the lightweight approach is to use our accelerator kit, which is basically a box with 20 devices with different sorts of sensors embedded in them. Comes with one gateway. It comes with ready-made dashboards, such as the one you've seen in the video. Comes with the positioning engine and 3 months of our support to maximize the outcome of it. And the questions you're gonna answer using the accelerator kit is the solution workable for me? What problems is it solving? What are my deployment challenges? And how much is it gonna cost for me in my application to get it all up and running? We see from customers that typically takes them between 1 week and 3 months to test drive their own application in the field using the accelerator kits and to evaluate the results. The second approach is to go to a pilot, to go immediately to a pilot, typically 50 to 100 devices, which are placed in the field in a running operation. It can be a running warehouse, can be a running production line with some heavy supply chains surrounding that. Comes with one gateway, although if you're planning to include multiple warehouses, we can provide multiple gateways, however many is required here. It comes with dashboards as well, which are customizable off the bat, and we're going to support you with that. We're also going to support you with integrating directly into your ERP WMS, because the goal of the pilot is really to have the system that you can then afterwards replicate throughout your operations. So if there's any integration required, we'll also support you in that. And just from experience, we see that it usually takes customers between 2 and 4 months to go through the process of installing the pilot, testing the pilot, and then making an evaluation how they're gonna continue to roll out throughout their operations. So that concludes at least my part of the presentation. Over to you, Mimi.
Well, thank you both, Ben and Nick. Those were really good presentations. I think we have now roughly 10 minutes for questions and answers section, and I think we have a big long list there. So guys, if you want to have a look at the questions list and pick some of the good questions, and I don't think we have time for all of them, but at least a few we can go through, and then rest we can then do offline one-on-one to the people who have asked the questions.
Yeah, absolutely. So thanks everybody for submitting questions. We did answer a number of them in the list. So if you I think actually we've gotten all of them answered in the list. So we'll talk about a few of them here. So one of the questions was about how many devices per gateway can be supported. You know, generally we're looking at 50 to hundreds. It really depends on the bandwidth that you're looking at. Each gateway can support about 150 packets per second. So that kind of gives you the rough throughput aspect there. That's 102 bytes per packet. So if you're doing more than that, you add more gateways, and that scales pretty much linearly. As you add gateways to the network, it rebalances itself to push that traffic towards other gateways that are less heavily loaded.
And there was a question about how accurate is a location engine. So from experience, we've seen that 2 to 5 meters is a very typical real life accuracy when you're using it indoors. And whether it's 2 or 5 depends, of course, on the environment. And we all know that wireless signals, that there is a little bit of inherent inaccuracy, but nevertheless, what we see is 5 meters is very consistent when you deploy your anchors on a grid of 15 by 15 meters, so 50 by 50 feet. So if you put anchors in that spacing, you typically get 4 to 5 meters. If you want to get down to the 2 meter level, then you just reduce the distance between your anchors to, let's say, 9 meters, about 30 feet. And then you get that to that better accuracy.
Yeah, so there was a couple questions around the cloud versus on-premise type solutions. So a couple points there. One of the great things that Redlore has done is implemented a bunch of the basically decision-making, machine learning type algorithms down at the device level. So that means that you don't need to push all of that data up to the cloud. Additionally, with the Wirepass engines, all of those can be run on the edge in a Docker container, and I believe for large applications, you can do the same at Redlore, correct, Nick?
Yeah, that is correct. I see a question coming in. What is the price structure for the Wirepass solution? So I think there's 2 sides to that question. The Redlore side, or the Redlore end of the answer, is all our devices come preloaded with Wirepass, and we have an arrangement with Wirepass that allows us to do that. So you, as a Redlore customer, you won't see any of that price. You just pay for our devices and a recurring revenue for the IoT cloud engine. Ben, maybe you want to speak about the.
Sure. And then from a Wirepass side, if you're looking to get that directly from us and integrate it into your own product, there's a small royalty per device, and then annual maintenance and membership fee, which is essentially like Bluetooth and Thread and Zigbee do, associated as well to be a Wirepass member, and that comes with all the support and documentation and code that you need to build your own device. There's another question about kind of getting, can Wirepass run on off-the-shelf Bluetooth devices? And the answer here is in many cases, yes, particularly if it's based around an NRF52 or EFR32 based part, both of which are extremely common Bluetooth chipsets. If you have any questions on that, feel free to reach out to us directly and we can help you figure that out. There's also a question about anchors and if you need anchors if you're not doing positioning, and the answer is no. An anchor is effectively the exact same thing as any of the other devices in the network, but it has a fixed location, so that the cloud or Docker container solution that's figuring out the positioning engine knows where that device is and can compute the location of the moving devices because of that.
And then I see a question about what kind of standards apply to the warehouse management application. So there's quite a bunch of standards surrounding warehouses done by VDI, done by ISO, and some are about safety, others are about quality. Now, what we found there where IoT solutions are really able to support warehouses and supply chains in general is around the ISO TS 16949 standard, which is used a lot in automotive, but also many other supply chain heavy industries have adopted this standard. It's basically ISO 9001 on steroids.
Yeah, there were a couple questions about comparing to other mesh networks like BLE and Thread. I've got a number of different articles and presentations on that. If anyone would like to learn more in detail, please reach out to anyone on the Wirepass team. Myself has been included. We'd be happy to get you information on that. We didn't go into that in detail today, but there's some very interesting aspects, particularly as you think about these type of warehouse type applications where both BLE and Thread struggle typically, that the Wirepass solution is really excelled in.
And then a question, does the RL4 sensor devices have an NRF52 system on chip inside? So the NRF52 is a Nordic chip that is one of the chipsets supported by Wirepass. So the answer is yes, the RL4 has an NRF52 inside.
Yeah, there was a question about running on other frequencies besides 2.4 gigahertz. We do have Wirepass mesh solutions on sub-gig for various different markets in the 800 and 900 megahertz ranges, primarily around the EZR32 platforms. And there was one question, looks like it just came in about speaking about the security solution. As we mentioned earlier, all of the Wirepass solutions are running on the entire network stack, or entire network communications layer is an AES 128-bit encryption with a rolling cipher that ensures you can't do replay. And all of the messages are ACT as well and resent in the event that they're not received. So that really gives you a lot of robust security in making sure that not only did it get there encrypted, but it got there at all. And so that's a bit on security. If you have more specific questions on security, I'm happy to dive in. Just shoot me an email.
And then a question about anchors versus tags. Our anchors and tags are basically interchangeable. Is that true? So technically, yes, you can use any tag as an anchor, or you could use an anchor as a tag. It's basically how you configure it. They're all part of the Wirepass mesh network, and they can all be either or. This being said, there is often a difference because tags will have additional sensors attached to it to detect things like fall and tilt and temperature, which are really not necessary in anchors. On the other hand, anchors often have a slightly bigger battery to give them a few more years of battery life. So yes, some of our customers have used them interchangeably, but in other solutions, we make a distinction between the two for those reasons.
Okay, well, I think we've got all the questions answered. I want to thank everybody for taking the time today. We'll be sending out a follow-up email with a link to this webinar and email addresses. So if you have any questions, please don't hesitate to reach out to anyone on the Wirepass or Redlore team. We'd be happy to answer any of your questions and point you to the right people inside of either company to get those questions answered. So thanks again for everybody joining. We really appreciate it. Have a great day.
Thanks from my side as well. Have a great day from me too.